Now let's talk about bond price, or say bond valuation. Based on the time value of money concept that we have learned from Chapter 4 and Chapter 5, the value of a financial security, it could be a bond, it could be a stock, depends on how much cash flow it can bring to its investors in the future. So the more money it can bring to the investors in the future, the more valuable it can be now. And because all the cash flows will be paid to the investors in the future, and the investors have to pay for the security now. So we are actually trying to calculate the present value of this security based on all the cash flows it can bring to the investors in the future. That's why you see this equation here, and if you look into it, you realize this is nothing different from what you have learned in Chapter 5 in terms of calculating the total present value of all the future cash flows. And we are using this little r here as a discount rate to calculate the present values. And this little r is called the required rate of return. So this is a return required by investors. So if we're talking about bonds, you can get coupon interest payments in the next couple of years, and then you will receive a lump sum payment at the end, or say when the bond matures. So all these CFs will be about the coupon interest payment and the par value payments at different times, different years, discounted by the required rate of return by the debt holders, or say the bond holders. Now let's look at maybe the simplest kind of bond, a zero coupon bond. A zero coupon bond is a bond that makes zero, or say no coupon payment. So all it pays is the par value at the time of maturity. So now if we look at an example here, we have a 20-year zero coupon bond. So this bond pays $1,000 at the end of the 20th year. If the discount rate is 6%, that will be the annual required rate of return by the bondholders, or say the investors who are willing to buy this zero coupon bond. So how much would they be willing to pay for this bond now in exchange for $1,000 in 20 years? Isn't that the same question as what is the present value for $1,000 in 20 years? So a typical discounting process, just like what you did in Chapter 4. Here, just be aware that if we assume semi-annual compounding or discounting, we are talking about every 6 months for 20 years. So that will be a total 40 times. And each every 6 months, we're using 3%, which is 6% divided by 2. So 1,000 discounted by 3% for 40 times, we are looking at a price that's just a little bit over $300. Between $300 now and $1,000 in 20 years, you see these zero coupon bonds can be sold at a substantial discount. We can also try to use the financial calculator, again, just like what you did in Chapter 4 to calculate the present value. Well, I didn't put it here on the slides. You can add it here. For the future value, we use 1,000 because that is the final amount you receive at the end of the 20th year. So if you do that, and then 40 as n, 3 as iy, you compute for the PV. The PV should be 306.56, which is consistent with what you can get from the equation. So that's the calculation of the price of zero coupon bond based on the semi-annual compounding. The semi-annual compounding or semi-annual discounting is a generally accepted way instead of using the annual discounting, because usually bonds pay coupon payments. If they pay every 6 months. I have one more question about zero coupon bond here just for your practice. If we are looking at a zero coupon bond matures in 15 years, interest rate is 5.75%. So the market interest rate 5.75% is the required rate of return for bondholders for the whole year. So that's why we're using half of that as a semi-annual interest rate. Now because we have 15 years, we're going to discount for 30 periods. So once you do the discounting process using the present value formula, you get the PV result as 427.27. You can also try the financial calculator. 1000 will be your FV. 5.75 divided by 2 will be your IY. Your N will be 30. Your PMT will be 0. And you compute PV, you will get the same results. What if now we have a bond that does pay coupon or have those fixed coupon payments? The idea is still the same. We're trying to calculate the total present value of all the interest payments and the final par value payments. Now it's just for the zero coupon bond, the interest payment, this whole part will be 0. And now for the fixed coupon bonds, or say for bonds that do have fixed amount of coupon payments, we have this part and they are not 0. So all those coupon payments amounts are the same every year or every 6 months, then we have an annuity here. So this is actually the annuity present value calculation. So now let's look at this example. If we have a 10% annual coupon bonds, every year the coupon payment is 10% of the par, which is $100. And they will pay $100 each every year for 10 years. So here N will be 10. At the end of the 10th year, this bond will pay a final lump sum payment of $1,000. This will be the last payment. And after that, this bond will be done. No more payment from the bond. And if we also have the required rate of return for the bond or by the bondholders as 10%, which is the 10% discount rate to calculate the present value. We can put all these numbers in the timeline. Again, $100 per year for the next 10 years. So we have a nice 10-year annuity here. And then extra $1,000 at the end. What we can do is to calculate the present value of every one and sum them up. If you want to do this for all the 10 years plus the final lump sum payments, and you sum them up, you get the value of this bond as $1,000. We can also try to use a financial calculator. This whole calculation is based on annual compounding or annual discounting. So we have 10 years, each year $100 payments, 10% discount rate, final lump sum payment $1,000. This is the additional $1,000 at the end of the 10th year. So this is a little bit different from what you did in Chapter 5 for those annuity calculations. Remember, for those annuity calculations, most of the times your FV will be 0. But here the FV is not 0 simply because here at the end of the 10th year, you do have this additional payment, the extra payment. So we put this $1,000 here as the last year, and then we compute for the future present value, and the present value will be $1,000, and that will be the price of the bond at time 0. So the negative sign from your calculator is about this idea. You have to pay $1,000 in exchange of receiving $100 each every year for the next 10 years and receiving final $1,000 at the end of the 10th year. Also in this case, because this number, $1,000, is exactly the same as the par value, we say the bond is selling at par. So here, what if we have a 13% annual coupon rate? So if we have a 13% annual coupon rate, then the annual coupon payment will be 13% multiplied by $1,000, which gives us $130 here. Between this one and the calculation you did before, as you see, the only change is the payment now is not just 100, but instead is 130. So now you know this is a bond that pays a little bit more coupon payments in the future. It should be pretty easy to understand now the bond price will be a little bit higher than the par, higher than the price you calculated here, because it would only be fair for you to charge a higher price for a bond that can make more money in the future, right? So in that sense, you see when the coupon interest rate is 13%, higher than the 10% required rate of return by the debt holders, the price of the bond is a little bit higher than the par value, or say the bond is now traded at premium. Now, what if the bond doesn't really pay that much? What if it only pays 7% coupon rate, therefore only $70 coupon interest payments? If you look at this one, comparing to the previous bond, you see only the payment now is different. So you compare the price, and the price now is $815.66. So if a bond doesn't pay much in the future, it only makes sense that today the bond will not be traded at a very high price. Now this bond is selling at a discount, meaning the price is lower than the par. So now if we want to summarize, when you have a bond that's coupon interest rate is 7%, which is lower than the 10% market interest rate, or say required rate of return by the debt holders, then you have a bond that's traded at about $800 below the par, or say this is a discount bond. And then when you have a bond that has a coupon rate of 13%, higher than the market interest rate, or say the required rate of return of 10%, then the bond will be traded at about $1,100, and that's above the par, or say you have a premium bond. So it's really about how much the bond offers, how much the bond coupon rate compares to the required rate of return of the bond, or compares to the market interest rates for those kind of bonds. If the coupon interest rate is exactly the same as the required rate of return, the bond price will be exactly the same as the par. So we just talked about pricing of the bond for annual coupon bonds with fixed amount of annual coupon payments. What if we have bonds that pay coupon payments semi-annually? For the semi-annual coupon payment bonds, essentially the same ideas, but we just need to make some adjustments. If we are looking at a 10-year semi-annual bond, because it pays 2 payments per year, then in 10 years it's going to make 20 payments. So the number of payments will be 2 multiplied by 10 to get us 20. Then every 6 months, that interest rate will be the annual interest rate divided by 2. So each payment every 6 months will be the annual payment amount divided by 2. What about the FV, or say the final lump sum payment? Well, that par value is the par value that would not be affected whether we have an annual coupon bond or semi-annual coupon bond. So FV would not change. It will be still the same $1,000. So now if we look at this example, we are looking at a 5.2% coupon bond, 18 years left to maturity. Market interest rate, or say the required rate of return, is 4.6%. Semi-annual payments. So what is the price of the bond? And then, according to the price, is this a discount bond or premium bond? Let's see. We are talking about 18 years. 18 multiplied by 2, so we have N as 36. 4.2% coupon, that would translate into $52 coupon payment every year. But since this bond pays semi-annually, or twice a year, then each every 6 months, you get half of the $52. So that's why you have 26 as payments. Nominal interest rate divided by 2. So 4.6 divided by 2 to get the semi-annual interest rate of 2.3. Final value is not affected. It will still be 1,000. So once you enter these numbers, you compute for the present value, it should be a little bit higher than 1,000 because your coupon interest rate, 5.2%, is a little bit higher than the market interest rate. Your price, 1072, that's a little bit higher than the par. This is a bond that is selling at premium. Now, once you understand all the bond price calculations, try the following questions. Calculate the price of the 30-year zero coupon bond when the discount rate is 6%. And then calculate the price for the same 30-year zero coupon bonds, but your interest rate now is not 6%, but 7%. Look at your results, see if the price has gone up or down when your interest rate goes up from 6% to 7%. You can also find out what is the change, or say how much in percentage has the price changed. Second question, very similar. Instead of now looking at a 30-year zero coupon bond, we are looking at a 30-year 5% coupon bond. What would be the price of this 30-year 5% coupon bond based on semi-annual compounding if the market interest rate, or say the required rate of return, is 6%? What if the required rate of return is not 6% but 7%? So also for this question, you are trying to calculate two prices. One is when the market interest rate is 6%, the other one is when the market interest rate is 7%. Third question is also very similar, but now we are looking at a 2-year 5% coupon bonds. So again, for this question, you are also trying to calculate two prices for the same bond, just change the required rate of return from 6% to 7%. So here I have the results for the bond prices for the three different bonds mentioned in the last slide under two different interest rates. For example, for the 30-year zero coupon bond, when the interest rate is 6%, you would calculate the price. Under semi-annual compounding, it will be this much, and under 7%, the price will be this much. Based on these two numbers, you can calculate the change. The change would be what you have under as a new price, 126.93 here, minus the old price, 169. So apparently that will be a negative number, and then divided by the original price of 169.73. So the change here means that once the interest rate goes up from 6% to 7%, this bond, this 30-year zero coupon bond, lost about a quarter of its original value. And then if you look at a 0.5% coupon bond, price was 981 and then dropped to 963, and that is about a 1.85% drop in its price. So what conclusion can we draw here? If you look at all these prices and also the percentage change numbers, first, you see that for all these three bonds here, when interest rate goes up from 6% to 7%, the prices all dropped. So generally, if the interest rate goes up, bond price will go down. If you look at different bonds, though, you notice that they experience different level of price drop. So for the 30-year 5% coupon bonds and the 2-year 5% coupon bond, they both have 5% coupon, but one is short-term, 2-year, the other one is long-term. So for the long-term bond, price change dropped by almost 13%. But for the 2-year bond, the price only dropped by less than 2%. So that's a much smaller drop. Now, if you look at a 30-year zero coupon bond versus the 30-year 5% coupon bond, they are both 30 years. So the maturity is the same, but one has decent coupon payments, the other one has zero coupon payments. So for the one with decent level of coupon payment, the price dropped almost 13%. It's a lot, but it's smaller than the 25% drop in the 30-year zero coupon bond. So, to summarize, if interest rates go up, then the bond price will have to fall. This drop in bond prices as a result of the rising interest rate. This is what we call as interest rate risk, or say interest rate sensitivity. Put it in another way, bond prices can be very sensitive to the change of interest rates. If interest rate goes up by a little bit, bond price potentially can go down a lot. But the interest rate risk does not affect all bonds equally. Sometimes we also say not all bonds have the same level of interest rate risk or interest rate sensitivity. Bonds with longer maturity have the higher interest rate risk. They are more sensitive to the change of interest rates. Bonds with higher coupon rate, they actually have lower interest rate risk comparing to the bonds with zero or low coupon rate. Now if I ask you, what two variables would affect the interest rate risk or interest rate sensitivity of a bond? You know the two variables, or say the two factors, are the maturity of the bond and the coupon interest rate of the bond. So now let's look at this question. Among the 4 bonds listed here, which one is most sensitive to 1% change of interest? Which one is least sensitive? So these bonds listed here, there are a 30 years 0 coupon bond, 30 year 5% coupon bond, 1 year 0 coupon bond, 1 year 5% coupon bond. So the one with the highest interest rate sensitivity would be having the combination of longest maturity and the lowest coupon rate. And that would be the 30-year 0 coupon bonds. The one with the shortest maturity and highest coupon rate, that will be the 1 year 5% coupon bond. This one actually will have the lowest interest rate sensitivity. So this is about the concept of interest rate risk or interest rate sensitivity. Bond prices can be very sensitive to the change of interest rates. And different bonds have different level of interest rate risk. It depends on the maturity of the bond and the coupon interest rate of the bond. We just talked about the interest rate risk for bonds. Usually if you hold some bonds, you are definitely concerned about this interest rate risk when interest rate goes up. But does that mean that you have nothing to be concerned about if the interest rate goes down? Well, if interest rates are going down or say are declining, the bonds actually have the so-called reinvestment risk. So you receive the coupon payments from the bonds, but what can you do with those cash now? If you reinvest them, you are subject to the lower market interest rate since the interest rate have declined. So that is what we are talking about as the reinvestment risk. In that sense, 0 coupon bonds actually have no reinvestment risk because there are no coupon payments from those bonds. So if interest rate goes up, we are concerned about the interest rate risk. If interest rate goes down, we're concerned about the reinvestment risk. So if you manage a bond portfolio, you have to be aware of how much of your bond portfolio value will be affected if the interest rate goes up, and how much of your portfolio value will be affected if interest rate goes down. So either way, you have to have a good idea about how your portfolio will be affected.